In the previous video, we put every one of these integrals as left and right Riemann summation. Now we're going to do it for the midpoint summation. So remember that the limit as n approaches infinity of the summation from the midpoint, the traditional way is to put it from I equals 0 to n minus 1 of f of x sub I. This time is f of x sub I plus 0.5 because we are taking the midpoint times delta x. So this is the same as the limit as n approaches infinity of summation from I equals 0 to n minus 1 of f of what's x sub I? X sub I was a plus delta x times I plus 0.5 because in our graph that is something like this, defined from a to b, our integral, we want to take the midpoint. The midpoint, these are the rectangles, the midpoint begins from a plus 0.5, and in the next one would be a plus 0.5 plus 1, etc. And we already do this in previous videos. And so would be limit from n as n approaches infinity of I equals 1 to n minus 1 of f of x sub I would be a plus delta x times I plus 0.5, everything times delta x. Or the limit in the non-traditional way would be the limit as n approaches infinity of the summation from I equals 0 to n minus 1 of f of a plus, 1 to n of a plus delta x times I minus 0.5 delta x. Alright, now let's put any one of these. Delta x from this would be pi minus 0 over n is pi over n. So, where is my eraser? Well, alright. So will be the limit as n approaches infinity of summation from the traditional way is I equals 0 to n minus 1 of what's x sub I first. This will be 0 plus pi over n times I plus 0.5. So f of this would be cosine of 5 over n, cosine of 5 over n times I plus 0.5 times delta x, that's 5 over n. Or the limit as n approaches infinity of the summation from I equals 1 to n of cosine of 5 over n times 5 over n. Sorry, I don't know why I put this. Pi over n, pi over n, pi over n, pi over n, pi over n of I minus 0.5 times pi over n. The other one for this would be delta x is 5, x sub I is 2 plus, delta x is 5 over n, 2 plus 5 over n times I plus 0.5. So this would be the limit as n approaches infinity of the summation from I equals 0 to n minus 1 of the natural logarithm of 2 plus 5 over n times I plus 0.5 times delta x, that is 5 over n, or all f of x, or the limit as n approaches infinity of the summation from I equals 1 to n of natural logarithm of 2 plus 5 over n of I minus 0.5, and all this f of x, all this times 5 over n. The other one would be here delta x is 3 over n, x is 3 over n. X sub I is 0 plus 3 over n times I plus 0.5. So this will be the limit as n approaches infinity of the summation from I equals 0 to n minus 1 of e to the 3 over n times I plus 0.5 times 3 over n, or the limit as n approaches infinity of the summation from I equals 1 to n of e to the 3 over n times I minus 0.5 all times 3 over n. This would be, here the delta x is 5 minus 0 is 5 over n. X sub I would be 5 over n times I plus 0.5. And so here will be the limit as n approaches infinity of the summation from I equals 0 to n minus 1 of x sub I is 5 over n times I plus 0.5 plus 1. This is our f of x, and all this times delta x, that is 5 over n, or the limit as n approaches infinity of the summation from I equals 1 to n of 5 over n times I minus 0.5 plus 1, all these times 5 over n. And the last one that doesn't depend on I would be the same as for the right and left Riemann summation, that is just, if we evaluate it, we have 20.